Hi, everyone.
Hello.
If you can hear, my cat has decided that she is going to talk to you during today's live stream. So you may hear that persistent meowing, but welcome to our second week of live stream shows. We're really excited with the shows we have coming up over the next couple weeks. I think we have some really cool stuff. Um, Quick introductions. I'm Jessica. I am the Planetarium director, and yes, I do have the most amazing job ever. On the stream, we also have Eli, who's going to be just a voice in the sky today. Eli, you want to introduce?
Hello. I am a physics student and planetarium worker at UMD.
And so Eli is going to be watching the chat for us and letting me know whatever questions come up. So if you have any questions, type them in the comments and we'll get to them. Just do note that there is a bit of a lag between when you post a comment and when we see it and get to answer, so it may be a couple minutes. But if we don't get to any of them throughout the actual talking about what we're talking about today, we will take time at the end to try and make sure we answer all of the questions that are there. So today we are going to be talking about moon phases and eclipses, which is a really fun topic and one that has a lot of common misconceptions with it. And so while I get my program started up, I'm going to turn off my video for just a second because my computer does not like to have the video and my software running at the same time. And we will transition over. So, the program we're going to be using to start off with here is something called Stellarium. This is actually a free planetarium software that you can download, and it allows you to set date, time, location, and it'll show you what's up in the sky. It's really easy to use, and as I said, it is free. So it's a really awesome thing to kind of explore, but this is what we're going to be using today. And so we have it pulled up for right now. We can see the sun all nice and high in the sky. It's a beautiful day out, but we don't see the moon up yet. And so to see the moon, we're going to need to go forward in time a bit. And so I'm going to fast forward. We'll see the sun as it moves across the sky, and we'll start setting in the west. But I'm going to turn over here in the east, because just like the sun, the moon also rises in the east and sets in the west. And so as the sun is setting, we will start to see the moon. There it is. So I'm going to let it get a little bit higher in the sky. And so we are right at the full moon. Last night was actually the full moon. For anyone who got to go out and see it. It is what is called the pink moon, which actually has nothing to do with the color. Every full moon of the month is given a certain name, and I don't know why or who came up with this. But the full moon seen in April is called the pink moon, and that's why. And so if we zoom on in, we can see our nice, big, full, beautiful moon, nearly full. But we want to see what happens as we move forward. And so I'm going to jump forward a couple days. And as we do that, we can start to see that we're seeing less and less of the moon. And as we keep going, we see that it has suddenly disappeared. Now if I zoom back out real quick, you can see that's because at this time, on this date, the moon's actually not up yet. And so we're going to need to jump ahead in order to see it. Zoom back in. Keep going. We're seeing less and less of the moon. and it's getting lower and lower in the sky, which means we're going to need to go forward in time some. Keep going ahead. Now we don't see the moon at all. And as we keep going, we now, start to see more and more of it. Jump forward in time a little bit. And more until we're back to that big, beautiful full moon. And so if you watch the moon over the course of the month, this is what you're going to see. You're going to see that the amount of the moon that we see slowly changes over the course of the month. First, we start off seeing none, and then we see more and more until we get the big, beautiful full moon, and then we see less and less until we're back to seeing none of it. And we can see it up at different times of the day. And so this is, of course, what we know as the phases of the moon. But there is a lot of misconception over what exactly is causing the phases of the moon. A lot of people, or not a lot, I say it is a common misconception that the phases of the moon are caused because of Earth's shadow. That Earth is casting a shadow on the moon, and that is what's causing the phases, but that's not the case. So we're going to jump up into space and take a look at what's actually causing the phases of the moon. And so right now, we're looking down on the Earth-Moon system. Note, this is not to scale at all, but if it were, we wouldn't be able to see as much detail. Over on the far left, you can see the kind of yellow glow that's telling us that the sun is over on the left. And then we have the Earth and the moon. And we can see for both the Earth and the moon that half of them are lit up by the sun, right? On the Earth, we have the left side is lit up. That's because the sun is on the left. And the right side is dark. That's where we're having nighttime. And we know that as the Earth spins over 24 hours, that's where we get our day-night cycle. Well, when we look at the moon, we see the same thing. The left side of the moon is lit up by the sun because the sun is on the left, and the right side of the moon is dark. Well, the way the moon is positioned right now, from Earth, we can see all of that lit up side, which is when we see this nice big full moon. But if we let the moon orbit around the sun, or orbit around the Earth, as it moves in its orbit, half of it is still lit up by the sun. The problem is, from our vantage point here on Earth, we don't see all of that lit up side. We're only seeing part of it, which is why from our view, the moon appears to become less and less full, less and less lit. And so as it continues in its orbit, we're going to see less and less of that lit up side. Half of it's always lit up, but we're just seeing less of that until it makes its way all the way around to the opposite side of where we started. And now the side that we can see is not lit up at all. And so we don't see any of the moonlit. But as it continues around, we can again start to see some of that lit side, and we see more and more of that being lit up. And so this is what causes our phases of the moon. And I'm going to back this video up to play it from the start again. So this is the cause. What's happening is half of the moon is always lit up by the sun, but as it's orbiting around the Earth, we see different parts of that lit up side. And so over the course of a month, as the moon is orbiting around the Earth, the amount of that lit side we see changes, and that's what gives us our phases of the moon. Now, I know even seeing it in this video, it can sometimes be difficult to grasp, especially for people who learn best by doing themselves. And so there is an easy way that we can do that. And so let me bring this back. Why is this? I'm very confused right now. Hold on. Oh, there we go. And transition over. Okay, so there is a really fun demonstration that you can actually do at home, showcasing the phases of the moon and how all of this works. And all you need is a light source, which can be a lamp, it can be a flashlight, or a flashlight on your cell phone. When I was testing this out yesterday and getting a good video, I just used my overhead kitchen light. So you need a light, a semi-dark room, and a ball of some sort. I happen to have some styrofoam balls because I like crafting, and I have lots of miscellaneous crafting supplies. I've stuck it onto a pencil just so it's easier to hold, but you don't have to do that. You could use, even if you have something like a soccer ball or a tennis ball, or if you don't have any good thing, you can even just use your fist held out. And so what it's going to end up looking like is, let me get out of this. As you hold your ball out in front of you, as you spin around, you're going to watch, you're going to see as the ball is lit up, different amounts. The part that's part of the ball facing you is going to be lit up at different amounts. And so as you spin, you can actually see these phases occur. And so it's a fun way to see it and do it yourself. All right, so what's actually going on here? Or what else is going on here, I guess I should say. Let me get this back up. There we go. Oops. Sorry, I'm having computer problems today, apparently, on this stream, but that's fine. Okay. And so, as you know, we have names for these different phases. I'm going to start over here at what we typically think of as the start of the phase cycle. And so when we can see none of the lit side of the moon, we call this the new moon. And then as the moon orbits, and we start to see a little sliver of the moon, we call that a crescent. In particular, this is a waxing crescent, and I'll tell you the difference in just a second. As it continues to orbit around, half of the side that's facing us is lit. We call this the first quarter. As it continues orbiting, we now see more than half, so we call that a gibbous moon. This is a waxing gibbous. And then, of course, what we know fairly well, let me jump back to over here, is when we can see all of that lit side, that's our big, beautiful full moon. And then as it continues back around, we then see it go kind of the opposite of what we started out with. We're going to see more than half but less than full, so that's another gibbous moon. But we're going to call this a waning gibbous. And then back to seeing half, which in this case we're going to call the third quarter. And then back to seeing a little sliver, which is another crescent, but this is going to be the waning crescent. And so the crescent and gibbous just describe the shape of the lit side that we're seeing, like the sliver of the crescent or the more than half, which is our gibbous. But our waxing and waning describe kind of which side of the orbit the moon's on, whether it's going from new to full or from full to new. And so the way that I remember it is for the waxing phases, that's when the moon is kind of turning on. That's when we're seeing more and more of it lit up, so it's wax on. And then for the waning phases, this is when the moon is kind of turning off. You're seeing less and less of it, so waning off. So I use the little trick of wax on, wane off to remember the difference between the two. So that is the names of our phases. Now, what we can also see as we watch the moon orbit around the Earth is we can kind of come back to something that we saw at the beginning in Stellarium. We saw that the different phases of the moon are up at different times. And this is really helping us to see this. And so when we look at our crescent, our waxing crescent, we see that the daytime side of the Earth is facing the waxing crescent moon. And so we can see this up in the daytime. Now, as the moon continues to orbit, and we move over to the gibbous, now the nighttime side of the Earth is facing the moon. And so we see this phase at night. And so over to the full, which we see at night. Waning gibbous, which is prominently up at night. And then back over to our crescents, which are back in the daytime. And so depending on what phase the moon is in, that's going to depend on whether it's up during the day or during the night. Our crescents are up during the day because the daytime side is seeing the Earth at that point. And our gibbous and full moon are up during the nighttime. And so that's another kind of common misconception. A lot of people think that the moon is only up during the nighttime, but as we can see, that is not the case. All right, so you may be wondering, when the moon is at the new moon, how is it that the moon is not just blocking the sun in the sky? Or if we go all the way over to our full moon, how is the Earth not casting a shadow on the moon and blocking the sunlight, keeping it from being a full moon? And that is a really, really good question. And so it turns out that we don't see the sun being blocked or the Earth blocking the moon during new moons and full moons because the moon's orbit is actually tilted by about 5 degrees. And so most of the time, the moon is going to pass either above or below Earth's shadow during the full moon. And most of the time, it's going to pass above or below the sun during the new moon. And so they don't actually all line up nice and neatly for things to get blocked out. But that doesn't mean that can never happen. About twice a year on average, the sun, the Earth, and the moon are all nicely lined up to block each other in the sky, and this is what can cause an eclipse. And so there are two different scenarios that you can have here. In the case that you have the sun, Earth, moon, and therefore the moon is falling into the Earth's shadow, you get what we call a lunar eclipse. Now, if you have sun, moon, Earth, the moon when it's lined up correctly, is able to block the sun from the sky on Earth and create a solar eclipse. Now, one thing you might notice is when a solar eclipse is happening, what's actually happening when the moon blocks the sun in our sky is it's casting a shadow on the Earth. But that shadow is quite small. It doesn't cover the entire Earth. And that's why you have to be in a very specific location to see a solar eclipse happen. You have to be within the moon's shadow. And this is what we call the path of totality, wherever the moon's shadow falls. And so you can see here the moon's shadow on the Earth. So anyone in that shadow will see the solar eclipse, and that shadow is going to move across the Earth as the Earth spins and the moon rotates and orbits.
So Jessica, really quick, we did get a question.
Okay.
Amy Coretta asked, does the moon ever get further away from the Earth?
Ooh, Amy bringing in the good questions. So, yes. The moon is actually very, very slowly moving away from us at about, I think it's 1/4 centimeter a year, which isn't a lot, but it is very slowly moving away from us. So that's a good question. All right. So yeah, because only that small portion of the Earth gets to see the solar eclipse at any given time, this is why they're considered pretty rare. Even though they happen with about the same regularity as lunar eclipses, a lunar eclipse, the shadow of the Earth is huge and easily covers up the moon. And so anyone on the nighttime side can see a lunar eclipse happen, whereas you have to be in that very specific spot where the moon is going to cast a shadow on the Earth in order to see the solar eclipse. Now, when we are able to see these awesome things happen, they look pretty spectacular. And so we'll start with the lunar eclipse, which is something most people have probably seen. So during a total lunar eclipse, you're going to start off seeing, and this video is sped up, less and less of the moon lit up as it's moving into Earth's shadow. But once it's completely in Earth's shadow, the moon doesn't actually disappear. It actually turns this bright coppery red. And that's why total lunar eclipses are often nicknamed blood moons. And then we'll start to see the moon moving back out of Earth's shadow. And so that is a total lunar eclipse. Like I said, this video is sped up. This actually happens over the course of several hours. Now, you may be wondering why the moon doesn't completely disappear, why it turns this red color. And that's actually due to Earth's atmosphere. Because when the sun's light hits Earth's atmosphere, the different colors of light coming from the sun kind of react in different ways. The blue light gets bounced all around, which is why our skies look blue in color. But the red gets kind of bent slightly. The path that the light is taking gets bent ever so slightly. And so during a total lunar eclipse, the moon happens to be at the right spot for that red light that's being bent just a little bit to fall on the moon. And that's what ends up giving it that bright coppery red color, and why we call those the blood moons. Now for a solar eclipse, leading up to the solar eclipse, you're going to notice that it's going to gradually get darker and darker until the moon is able to fully cover the sun in the sky, at which point it gets about as dark as kind of a deep twilight, and you'll be able to see this wispy haze around the sun, which is actually the outer atmosphere, the corona of the sun. And these, while it doesn't happen as quick as this video is showing, do tend to be faster than a total lunar eclipse. So a lunar eclipse can last, as I said, for several hours. With that blood moon, when the moon is fully in Earth shadow, itself lasting maybe an hour. The solar eclipse is much faster because the moon shadow is small and moves quickly across the Earth. And so you will see a total solar eclipse for a couple minutes if you're lucky. I think the longest possible duration for totality of a solar eclipse is about 7 minutes. So that's another reason why they're kind of hard and rare to see. All right, so with all of this awesome stuff, you may now be wondering, how can I know when this is happening? Well, in the description for this live stream, I have posted a link to a website that tells us when the upcoming eclipses are here in Duluth. So I'm going to change this from the next 5 to the next decade. Now, this year, we unfortunately don't have any good eclipses. We have what's known as a penumbral lunar eclipse. This is not something you can really notice with your naked eye. The moon will dim just ever so slightly, but it's not going to be that full total blood moon that we saw in the video. But next year, we will have a couple of decent partial lunar eclipses where we will see that kind of dark shadow of the Earth crossing over the moon. And we'll also see a partial solar eclipse, which is going to be really awesome. And we will definitely tell you all about it, remind you about it when this is coming up, and also give you some tips for how you can safely watch this, because as always, you do not ever look directly at the sun. But we'll give you some cool ways to help you be able to see this. Although I think it's happening at like 5:30 in the morning. So I don't know if I'm going to wake up for that. We'll see. And then coming up in 2022, we have some good total lunar eclipses and another partial solar eclipse. And so we've got some good stuff coming up over the next few years. And we will, of course, post information when anything comes up. We'll try and hold some viewing parties at the planetarium, but you can always reference this link and take a look at what's coming up next. All right. So that is all about the phases of the moon and eclipses. Hopefully this has been entertaining or educational. And yeah, Eli, do we have any more questions?
Nope, nothing in there right now.
All right, well, we'll give you a couple more minutes. If you have any questions, to put them in the comments and we'll get to them. While we wait to see if any more come in, let me tell you what we have planned for the coming week for our live streams. On Saturday, we're going to do a live stream about citizen science. And so we're going to tell you all about how you can do real astronomy research from home and contribute to research that's ongoing. And it's not as difficult as you may think, and it can actually be a lot of fun. And then next week, on Wednesday, we're going to do a constellation story time where we will show you what constellations are up this time of year and give you some of the fun stories behind the constellations and give you some tips on how to find them yourself whenever you go out at night. And then next Saturday, we're going to be doing, what did I call it? The Scale and Wonders of the Universe, where we'll explore exactly how big the universe is and look at some of the really awesome things that are in it. And so that's going to be exciting. I know Eli is working on that one. He's going to be leading that one next weekend. So, any comments?
No questions. Nope.
All right. Well, I guess we'll call that for today then. Thanks everyone for joining us. As usual, I guess I haven't said this on a stream yet. We now have our YouTube channel set up. I've linked to that in the description for this live stream as well. And so all of our live streams are going to be archived on our YouTube page so that you can go and watch them at any time. And so, yeah, with that, I guess we will say goodbye and see you on Saturday. So, bye, guys.
Oh,